Hello everyone, and welcome to Earth Archives. Today, we will explore a deeply profound question that might change the way you perceive time. What exactly is time? Is it really a straight line, constantly moving forward no matter what we do? Or is time just an illusion created by our brains, not as simple as we understand it to be? This question may sound abstract, but don't worry. Today's content will guide you through a deep exploration, from the most classic physical theories to thrilling cosmic phenomena, helping you rethink concepts like past, present, and future that are so familiar to our everyday lives. First, we need to start with a fundamental perspective. Is the time we feel every day really as direct and linear as we think? Many people say time just moves forward, always flowing at an unstoppable pace. But if we observe closely, things are not so simple. Have you ever noticed that sometimes time seems to pass very quickly, while at other times it feels like it's dragging on? All of this is actually related to our perception of time. Imagine this. What if we could, just like the characters in science fiction movies, board a spaceship traveling at near the speed of light? After flying for several years, we return to Earth and discover that we're much younger than the people who stayed behind. This isn't fantasy. It's a fact revealed by Einstein's theory of relativity. This leads us to one of the key concepts we'll discuss today, time dilation. Simply put, when you move at extremely high speeds, time passes more slowly for you, while time on Earth continues as usual. As a result, when you return, you'll find that the world has changed. Today's discussion will help you understand how time works in our lives and unravel some mysteries of the universe. As we dive deeper into these complex scientific theories, you might begin to see time in an entirely new light. Are you ready to explore this fascinating topic together? What is time? Does time really have an order? All right, take a moment to relax and stop looking at your watch. Don't rush to check the time, because today we're going to do a little experiment to help you rethink the passage of time. This question has puzzled philosophers and scientists for centuries, and even Einstein's theory of relativity, proposed in 1915, completely overturned our traditional view of time. Have you ever wondered how time actually works? Does it always flow in one direction? Do the past, present, and future follow a fixed order? If we could break free from these conventional thinking frameworks, might we discover that time isn't as simple as we understand it to be? Imagine this. When you watch a clock ticking relentlessly, with the minute and second hands moving in circles, time seems like an irreversible, constantly flowing river. But according to Einstein's theory of relativity, time is not fixed. In fact, it's a relative concept that changes depending on the observer's speed and the strength of the gravitational field. Does this sound a bit hard to grasp? Imagine traveling at near the speed of light. Time would slow down dramatically for you. Similarly, in a strong gravitational field, like near a black hole, time would also pass much more slowly. This is why, if you're standing on Earth and a few hours pass, astronauts in space might experience a different flow of time. But this isn't just the fascinating part of science. It also ties into some interesting phenomena in our daily lives. For example, have you ever experienced that feeling of time flying by or time dragging on? It actually has to do with your mental state. When you're busy or excited, time seems to pass in the blink of an eye. But when you're bored or anxious, time feels like it's moving at a crawl. This is why our perception of time can vary in different situations. Einstein's theory of relativity. Time is no longer absolute. Let's start with Einstein's general theory of relativity. You may have heard of this theory, but do you know how it changed our understanding of time? In 1915, Einstein proposed a groundbreaking idea. The laws of physics are the same for all non-accelerating observers. What does that mean? Let's imagine you're standing on the side of the road, watching a car drive by. You would assume that the passengers inside the car are moving at the same speed as the car itself, because, relative to you being a stationary observer, they are both moving at the same speed. But what about the passengers in the car? They don't feel like they're moving. For them, the car's speed is synchronized with their own. Their world feels stationary, and they don't perceive the motion of the car. This is the core concept of Einstein's relative motion. An object's motion is relative to the observer. This means that different observers can have different perceptions of the motion of the same object. This theory can be applied to all objects in the universe, no matter how big or far away they are. But there's one exception: light. No matter where you are in the universe, the speed of light is always constant, and this is the most crucial part of Einstein's theory. This discovery led Einstein to propose a new concept: space-time. This concept is very different from our everyday understanding of time and space. Traditionally, we think of time and space as two separate things: time as a straight line, and space as the stage where our daily activities unfold. However, Einstein's theory suggests that time and space are not separate. They are actually intertwined: space-time. This means that the way an object moves through space affects the passage of time, and the passage of time also affects how an object moves through space. In other words, time is not an absolute, fixed thing. It is relative and changes depending on the observer's position and speed. This explains why, in Einstein's theory, time and space are not discussed separately, but are understood as a unified concept of spacetime. This understanding encourages us to rethink the flow of time. Traditionally, we believe time was linear and always moved forward, but with the advent of relativity, time begins to show flexibility, influenced by gravity and speed. When you're standing on Earth, time passes more slowly compared to an astronaut in space. This may not align with our intuitive experience, but it's a phenomenon confirmed by scientists through experiments and observations. Spacetime, the close connection between time and space. Einstein's concept of spacetime tightly links time and space, causing us to no longer see them as independent entities. In fact, this theory suggests that the passage of time is not the same for everyone. Have you heard of the relativity of time? Simply put, this means that two different observers, one standing still and the other moving at an extremely high speed, will perceive time differently. This is not just a theory. It is a truth that has been confirmed through numerous experiments. Imagine this scenario. You and a friend are in different locations, each holding a clock, and you start timing. You are standing still on the ground, while your friend is aboard a spacecraft traveling at near the speed of light. According to Einstein's theory of relativity, you'll find that your friend's time passes more slowly than yours. In other words, even though you and your friend start the timing at the same moment, when your friend returns to Earth, the clock on their spacecraft will show less time than yours. This is the phenomenon known as time dilation. This seemingly absurd conclusion has actually been proven through many experiments. Scientists once used highly accurate atomic clocks, placing one on an airplane and the other on the ground. After the airplane completed a long flight, the time difference between the two atomic clocks was clearly visible. This is not just a theoretical hypothesis. It is an observable phenomenon. Why does this phenomenon occur? Einstein's theory tells us that when an object moves at a speed close to the speed of light, time becomes slower for that object. This happens because the object's motion causes the flow of time to behave differently. This also means that for observers in different speeds or gravitational fields, time is no longer absolute and fixed, but rather a relative concept that changes depending on the observer's state. This theory has overturned our traditional understanding of time, transforming it from an unchanging backdrop into a variable that changes with the environment. It has also opened up many new fields of scientific exploration, from quantum physics to astronomy, where understanding many phenomena now relies on this new perception of time. In summary, time is no longer a linear, unchanging flow. It is an elastic, variable existence, which provides us with a deeper understanding of the universe and the laws of physics. The passage of time, different speeds, different perceptions. Imagine this. If you were sitting on a fast-moving spaceship, your time would pass more slowly compared to someone on Earth. Sounds a bit unbelievable, right? But this is exactly the phenomenon of time dilation, which also explains why American astronaut Scott Kelly, after spending an entire year on the space station, was 13 milliseconds younger than his twin brother. This is a truly fascinating and surprising phenomenon, isn't it? However, this isn't a plot from a science fiction novel. It's a real discovery made by scientists after numerous experiments and observations. This concept comes from Einstein's theory of relativity. According to relativity, when an object's speed approaches the speed of light, the time it experiences will slow down compared to a stationary object. Simply put, when you're on a spaceship moving at near light speed, the time you experience will pass more slowly than for someone standing on Earth. Imagine you're aboard this spaceship, after flying for a while and then returning to Earth. You might discover that hundreds of years have passed, while only a few years have gone by on Earth. Doesn't this give you a whole new understanding of how time flows? This phenomenon is called time dilation, and it has actually been confirmed theoretically long before. American astronaut Scott Kelly spent a year on the International Space Station, while his twin brother stayed on Earth. When Scott returned to Earth, scientists discovered that he was 13 milliseconds younger than his twin brother. This is a real-life example of time dilation. Although 13 milliseconds may not sound like much, this experiment proved that when our speed approaches the speed of light, time flows at different rates. This theory not only gives us a completely new understanding of the passage of time, but also challenges our long-held traditional view of time. Time is no longer fixed or unchanging. It varies depending on your position and speed. Such discoveries not only have profound implications for physics, but also invite us to reflect more deeply on the nature of time and the universe. So, the next time you look at a clock or think about how quickly time passes, you might find yourself pondering a new question. How does time really work? The speed of light. Why can't we ever exceed it? Let's talk about the speed of light. When you look up at the night sky and see those twinkling stars, remember that the starlight you're seeing is not light from the present moment, but light from several years ago. You might wonder, why is there a delay in the light we see from stars that are so far away? The reason is that the speed of light is limited. For example, Proxima Centauri, a star about 4 light years away from Earth, sends out light that takes 4 years to reach us. In other words, the light you see now actually left that star 4 years ago. This means that if Proxima Centauri exploded, we would have to wait at least 4 years to know about it. Isn't that fascinating? The reason behind this phenomenon is that the speed of light remains constant throughout the universe, no matter where you are. According to Einstein's theory of relativity, the constancy of the speed of light is a fundamental physical principle. This principle means that whether you're standing on Earth or flying in a spaceship at high speed, the speed of light is the same for you. It's one of the fundamental rules of the universe. However, the constancy of the speed of light also brings many surprising results, such as time dilation, the concept we discussed earlier, which makes us rethink the relationship between time and space. Since the speed of light does not change with the observer's motion, our observation of light, whether from the past or the present, will always be influenced by this time delay. This is why, when we observe the light from distant stars, the light we see is actually from years ago, because it takes time for the light to reach our eyes. This phenomenon also gives us a new understanding of the time and distance in the universe. When we look at the night sky, we are actually looking into the past. All of this is determined by the constancy of the speed of light, which becomes key to explaining many cosmic mysteries. So, the next time you gaze at the stars on a clear night, remember that the distant starlight you're seeing is a witness to your journey through time and space. Past, present, and future. Do they really exist separately? Now let's explore an even more astonishing question. Do the past, present, and future really exist separately, as we understand them? This question has sparked significant discussion in the field of physics. According to Einstein's theory of relativity, the past, present, and future are not independent and separate. Instead, they are interwoven, and you could even say they all exist simultaneously. Imagine this. If we were to send an astronaut to a planet 4 light-years away from Earth, his present would occur 4 years after the present on Earth. This is because, for him, Earth's present has already become his past. In this case, the time at the two locations is not synchronized. This presents a huge challenge to our understanding of time. How exactly does time work? Is it really flowing in a fixed sequence from the past to the future, as we usually understand it? Relativity tells us that time is not an independent, fixed flow. It is closely linked with space, forming a structure called spacetime. This means that for different observers, the flow of time is different. Each observer's present is relative, not unique. For one person, their present may be someone else's past, if that person is in a different location. This concept forces us to rethink the nature of time. We habitually view the past, present, and future as linear and separate, but within the framework of relativity, they are actually interwoven. This interwoven view of time challenges our fundamental understanding of the world and deepens our insight into how the universe works. If we extend this concept further, we could even say that the distinction between past, present, and future is merely based on our human perspective and experience. What we perceive as the present might be viewed as the past or future from the viewpoint of another observer far away. This not only changes our understanding of time, but also leads us to consider that perhaps the time of the universe is not as simple and understandable as we once thought. It is far more complex and diverse than we can imagine. The illusion of time. It may just be an illusion. There's a theory called the moving spotlight theory that attempts to explain why we perceive time as linear and flowing. The core idea of this theory is fascinating. It suggests that there is actually only one absolute present, and this present moves like a spotlight, continuously illuminating a particular moment. Just like a spotlight constantly moving forward, this point of light always stays on a specific now. And as time passes, this now continues to move forward. In other words, the past, present, and future actually coexist. They are not separate, nor are they arranged in a straight line as we typically understand. The so-called feeling of time passing is actually an illusion created by our brain. Our memories and past experiences make us feel the flow of time, and our plans and hopes for the future make us feel the progress of time. This concept changes our fundamental understanding of time and challenges our previous simple notions of it. When we view the past, present, and future as independent events occurring in a fixed sequence, we actually overlook the fact that time is a relative concept. Its passage is not absolute or fixed, but rather influenced by our perception and way of thinking. So why do we feel time flows linearly? In fact, this is not a characteristic of time itself, but rather a sensation created by our brains when processing information. Based on our memories, experiences, and expectations for the future, we piece together these fragmented moments, creating a sense of order in time. This makes us feel as though time is always flowing from the past to the future. Yet, on a cosmic scale, this sense of flow is actually relative. This leads us to question whether time is really as real and fixed as we think it is. Perhaps it is more of a construct in our minds, varying depending on how we perceive the world. The passage of time is not just a result of physical processes. It is also a product of how we understand the world, our self-awareness, and our expectations for the future. Time, perhaps, is just a sensation of yours. Now you might be starting to feel a bit confused, maybe even experiencing a sense of existential crisis, but don't worry. These reflections don't need to cause you fear. In fact, this is the beginning of a profound exploration of the universe and time. No matter what your perception of time is, whether you enjoy nostalgia and reminiscing about the past or prefer living in the present, none of this will change your position and existence in the universe. The flow of time does not alter your true self. Imagine if you could travel at an incredibly fast speed, close to the speed of light. When you return to Earth, you would find that centuries have passed here. However, you would still find your original position in time. Only now, that time would no longer be the time you're familiar with. It would become more complex, more ambiguous. The time you experience and the time you perceive would be completely different from the time on Earth. But that doesn't mean you would lose your now. Even if you step out of this fixed time frame, you would still be able to find your place in the fabric of the universe's spacetime. Perhaps this is the mystery of time. It's not just a tool we use to measure life. It's a relative concept that changes according to our perspective and experience. Between different speeds and different observers, the flow of time is indeterminate. It seems solid as a rock, yet it becomes fluid and variable with each person's existence. If you've ever wondered whether time is truly an inherent entity, you may be getting closer to the answer. From a certain perspective, time might just be an illusion, a construct created by our brains to help us understand the changes in the universe and in life. This perception is built upon our memories, expectations, and experiences. Every moment, every second, flows in constant construction by our minds. After reading this, have you begun to rethink your understanding of time? Perhaps you now have a new perspective on the passage of time, or maybe some questions are lingering in your mind. After all, what exactly is time? Why is it so elusive? Is it really as fixed as we understand it to be, or is it simply a perceptual framework our brains have created for convenience? Each person's understanding and experience of time is different, and that's what makes it so fascinating and mysterious. If you have any new thoughts or questions about time, feel free to share them in the comments below. Let's discuss and explore this topic together. And don't forget to like and subscribe to the channel so you won't miss more interesting content. See you next time.